Everyone, welcome to Last Minute Maths. And a lot of my students have been asking me for a solution for the last question in this year's GCSE Edexcel Maths Paper 2, the higher paper. And the question was question number 23, according to this. And it's a bit of an odd one, and we're going to dive straight in. I'll just give you a solution, and hopefully you can compare it and remember whatever you put in the exam, and hopefully you got it right. Okay, you've got a quadrilateral. It's labeled. You can all read it. There are three sides given and two angles opposite each other, as you can see. All right, there and there, and the sides 6, 9, and 12. The problem is they're asking us to find the angle ABC. Oops, let's put that there. And the angle ABC, all right? And there is no easy way. You can't slice it up into triangles or anything like that immediately, okay? So we're after angle ABC to the nearest degree. All right, so how are we going to do this? Let me just undo all of that scribbling, and I'll show you. First thing to consider, the line DB, okay? And if we think of that, and we look at this triangle here, the larger triangle, we can actually use the cosine rule to find the length of dB. Quick reminder, cosine rule, a squared equals b squared plus c squared minus 2bc cos a, all right? And using that formula, we can see that if we label this one B, that one C, and this is going to be angle A, all right? And therefore dB is effectively side A. Using that information, we go straight into it. So 9 squared plus 12 squared minus 2 times 9 times 12 cos 60. Now it's calculator paper, so you don't need to worry about causes and sines and whatever. Just to get this thing moving, so you've got 81 plus 144 cos of that minus 108. Okay, so just quickly in my calculator, plus 144 minus 108. You get 117 for a squared, and a therefore turns out to be 3 root 13. Okay, I'm writing it in cert form. I just don't want to have to write out lots and lots of figures just yet, so we'll store that for a moment. So now that we know what dB is, okay, we can now use that and then use the sine rule to find various bits along here. So let's apply it to angle ABD. All right, let's do it that way. ABD. Okay. So what's going to happen is that we know this side 6, AD, is opposite to the angle ABD. All right. And the side that we've just found, DB, all right, the A, is opposite to that 125. So using the sine rule, we're going to say the following. Sine of angle ABD over 6 equals sine of 125 over the side that we just found, which was dB, and that's 3 root 13. Okay. Rearranging that, we can see that sine of angle ABD is going to be, just putting this straight into the calculator, so sine 25 x divided by 3 because Okay, 0.4543837, etc., etc. Don't need quite so many, but there's lots more. Therefore, angle ABD is the inverse sine of all that, and that comes out to be 27.025, etc. All right, so that's the first bit of information we've got. We're going to do exactly the same thing now for angle CBD, right, which is this one here. Okay, so that one relates to the side with length 9 centimeters, and again, the dB that we found right at the beginning, side that's 3 root 13, relates to the angle at C, so 60. All right, so using the sine rule a second time, we get sine of angle CBD over 9 equals sine of 60, again divided by 3 root 13. All right, so I'm just going to quickly do this. And it comes to sine angle CBD equals 0.72057, and so on. Okay, therefore angle CBD equals bear with me, 46.10156, etc. And therefore, when you put the two angles together, all right, you will get the whole of angle ABC, which is what we were after originally. Therefore, angle ABC equals, and remember it's to the nearest degree, so 46.10156, etc., plus 27.025, etc. The whole thing to the nearest degree, 73 degrees. All right, so that should be the correct answer. Obviously, I don't have access to a mark scheme or anything like that, but that's the best solution that I could think of. I hope it helps you. If you've done that paper and you struggle with that one, then hopefully you got it right. And if not, then it's worth noting the method in case something, if not similar, but the cosine and sine rule comes up again in paper 3, perhaps in a week and a half's time. So if you're in your exams, good luck. Hope it all goes well. Thank you for watching.